Hey folks, it's Mike from Cymulate, and welcome to a technical overview of the Cymulate system. What we're looking at here is the Cymulate dashboard. This is the main command and control interface for our SaaS-based continuous security validation platform, and you will be using this to set up different types of simulations and assessments that can be performed with Cymulate. So let's have a look first at some of those assessment types. We can use the Recon module to simulate intelligence gathering, finding data that's available in the public sphere, both in the clear web and dark web, that an attacker could use to plan or further an attack against your organization. From there, an attacker would need to infiltrate. They could do that by overcoming technology, and so we have three different vectors that test the different edge defense technologies that may be in use at your organization. Email gateway looks at everything from the outside world to a user's mailbox, including first and third-party solutions. Web Gateway looks at anything controlling data flow into and out of a secured device or secured network, so firewalls, proxies, VPNs, etc. Web App Firewall looks at defenses around websites and services and servers. It could be a traditional WAF, but it could also be hardening techniques against systems and services themselves. If an attacker is able to infiltrate, then they will attempt to compromise an endpoint. And that could be a desktop, a laptop, a VM, a server, a cloud instance. All of these types of endpoints can have various first and third-party defensive solutions in place, like anti-malware systems, Active Directory group policies, UAC, etc. And so our endpoint security vector is used to test the effectiveness of all of those types of solutions. If they do compromise an endpoint, unless they're lucky, it is not going to have exactly what they want on that one endpoint alone, and so they're going to propagate through the network. And we could simulate that with our lateral movement module. It's a true land and pivot lateral movement simulation, so we're using the same techniques that threat actors would be using, but like our other vectors, lateral movement is non-disruptive and non-destructive. And so you'll be able to perform this type of simulation against production networks without running the risk of damaging users, their data, or their systems. Data exfiltration is the final stop, especially if the attack is not designed to be merely disruptive or destructive. The data exfiltration module is designed to allow your organization to test the effectiveness of data loss prevention systems and other technologies designed to stop data from being moved outside of your sphere of control. You'll notice that we have a couple of other vectors as well, most notably immediate threats intelligence, which looks at micro simulations not focusing on any one particular set of security controls, but rather looking across all of the control sets that would defend against or deflect that particular threat. And full kill chain, which allows your team to create full kill chain threat simulations, similar to what we're doing with immediate threats, but with a lot more flexibility, and built from building blocks provided by Cymulate so that you know that they are indeed still non-disruptive and non-destructive. We also have a vector called Purple Team that allows your employees to create highly customized attacks that can even be disruptive using your own executables, executable code, and other types of configuration components, in addition to the over 800 different resources that we provide out of the box, to really create exactly the type of attack that you want to simulate. Now, you'll also see in each one of these vector readouts here on the dashboard, there is a score out of 100. That is the Cymulate score. Cymulate scores are the results of an assessment compared against 4 security frameworks: NIST 830, CVSS 3, Microsoft's version of the DREAD framework, and the MITRE ATT&CK framework. The system does the math and produces a unified score from 1 to 100, where higher scores indicate higher risk. As you can see, in this particular lab environment, we're not doing too well, but that was done on purpose so we could show you all of the interesting features and utilities built within the Cymulate system. Now that you're familiar with a bit about what we do, let's talk about how the Cymulate system works. Let's start with something like Endpoint Security. In the Endpoint Security module, your team will be able to create simulations that test out the effectiveness of anti-malware solutions, both traditional signature-based and next-generation behavioral-based, as well as first-party tools like user account control and permissions. The way that it is accomplished is similar across all of our vectors. You're simply going to tell the system three things: what, where, and when. What is defined by a template. It's a playbook or runbook and instructs the system on exactly what types of simulations you want to perform. Every vector has several different templates built in out of the box that are kept updated by the Cymulate team for easy access and quick access to common testing procedures. Of course, your team can create custom templates anytime they need by using the new template feature. It'll walk you through a wizard where you could select exactly what types of simulated events you want to occur. But if you're just starting out and you have a next-gen anti-malware system, for example, then you could go with Cymulate best practice. And selecting that template on the right, we could see that there are a bit over 2,300 known signatured malware files. These will be sent in batches so we don't disrupt or overload the network. Written to disk, monitored for 2 minutes, over which time they will be accessed but not executed. The goal of this phase of the simulation is to test signature-based anti-malware tools. Hopefully all of these will be quarantined or destroyed by an anti-malware tool, but in the event they're not, the Cymulate system will remove them automatically at the end of that 2-minute period. In addition to test next generation and behavioral-based type tools, we have a bit over 300 scenarios. These are used in many of our different vectors, and scenarios are independent executable files. Each one has been created by the Cymulate team from the ground up, and each one will step through the methodologies and techniques used by a specific type of attack. They're spread across 3 categories: ransomware, Trojans, and worms. And if we used ransomware as the example, a scenario when it executes may attempt to elevate permissions, or to manipulate scheduled tasks, or to inject a DLL. It will, if it is allowed to progress to the end without being stopped by a first or third-party security control, encrypt a directory of data created by the Cymulate system for that explicit purpose. And that allows us to both ensure that we know that this system can or cannot deflect that type of attack, but at no time do we put the environment or its systems or its data in any real risk. So these combined create the Cymulate best practice. The second component is where. And this is an agent-based simulation. Some of our simulations are agentless. Some are agent-based. In this case, it is agent-based. Agents are deployed 1 per environment. So you're not going to be deploying these to all of your systems or even close to that. As you can see here, this also lists that we have an integration with a third-party tool. To clarify that, Cymulate can take advantage of API access to third-party tools like anti-malware tools, SIEM solutions, vulnerability scanners, even some source solutions. But it does not change the methodology that we use to perform the assessment. Separation of duty is always maintained. What we can do with these integrations is allow you to get additional information as part of our reporting, which we're going to be looking at in just a moment. So if you choose to integrate, we can give you more info as part of the report. But if you do not choose to integrate, you will still get the same type of assessment as you would if you had chosen to link us to a third-party tool. In this case, we've selected a particular device that we will be using to perform the simulation against. That device, of course, would be configured with my anti-malware and my first-party tools and other types of security controls. And then finally, you define when. That could be a one-time simulation where you're spot checking something or you do want to do a quick verification of something, or a daily, weekly, or monthly recurring simulation. Many of our customers choose monthly simulations under normal circumstances, but choose to add in additional simulations on possibly a weekly or even daily basis when changes are occurring within the environment. This way they can make sure that nothing is falling through the cracks during new system deployment or significant changes to existing systems. Also keep in mind that these toolsets can be used to help with vendor selection. By running the exact same objective test against multiple vendors, you'll be able to quickly and easily define which tool best suits the needs of your organization. Let's talk about reporting. So once a simulation is complete, and that's usually a time span that's rated in hours, you will be able to see the reports for that assessment immediately. So if we jump into endpoint assessments, and I'm going to scroll back a bit because there's one in particular I want to take a look at. Now this is one that we stopped partway through. It was done with Sentinel-1. And Sentinel-1 does signature scanning, but it does it in a delayed fashion. So we stopped it during that process. However, it does let us get a very good view of how effective the behavioral-based detection systems are working. In this case, we could see that it caught all of the worm scenarios that we tried to run against it. But it had some trouble with ransomware and with Trojans. For example, a little over a third of the ransomware was able to execute. So if I click into that tile, I could see each and every scenario. Now, since I've chosen to integrate with that third-party tool, I could see all three, green, amber, and red shields on these scenario overviews. Green shields indicate that the third-party tool definitively stopped. We have proof that it stopped the simulation from completing. Amber indicates that the scenario itself was stopped. It is a good result, but there's no indication that the third-party tool stopped it. It could have been permissions or user access control or a group policy. It's still a good result, though. But we do want to check and make sure that the third-party tool is indeed seeing that activity, just to be safe. And of course, red indicates that the simulation was not stopped by either first or third-party tools. So let's take a look at this one. And in Sentinel-1's defense, we did disable a particular feature to allow this one to complete. And as you can see, it's displaying every step that occurred during the simulation and each event that was simulated, including the encryption of a file, a directory on disk. And we can see here that that directory is one created by the Cymulate system so that this could be used safely and effectively at the same time. And for each item, for example, an untrusted application, an unknown application on top of that, touching the control panel on a Windows system, there will be a More Info button. This will show us several pieces of information. First is a description of the technique, and for those techniques that align with the MITRE attack framework, a link directly to the MITRE tactic or sub-tactic. How to detect it, and of course, how to mitigate against it. And we'll always provide the most mitigation methodologies that we possibly can. Mitigation is rarely a one-size-fits-all type situation. And so in this case, we could use first-party tools like software restriction policies or user account control to stop this type of threat activity from being successful. We could also use third-party tools that allow the definition of trusted and untrusted applications, and then only allow trusted applications to touch the control panel, and block them if they are not on that list from touching sensitive or privileged operating system components. So your team would be able to determine the best course of action from the given selections available here, and then enact that particular solution and retest to ensure that you have indeed blocked off that methodology from being successful in your environment. Now, as I mentioned, if you choose to integrate, you could see some additional information. Everything we've spoken to up till now is going to be the same whether you integrate or not, but should you choose to integrate with EDR systems or several of our SIEM solutions or any one of our vulnerability solutions. Now, if I were to bring up something, for example, like email gateway, what you will see is that the methodology for creating the simulation is nearly identical. You will define what, where, and when, just as we did with Endpoint, only here you're defining what types of simulations should be performed against first and third-party email gateway systems. These are things like G Suite's Gmail platform, Microsoft's Office 365, Proofpoint, Mimecast, and other third-party email defensive tools. So you'll define what types of simulations you'd like to perform, from confirming file exclusion policies through testing, sandboxing, and content disarmament reconstruction systems. The where, in this case, will be an email address of your choosing, and so this is an agentless simulation methodology. And the when will be the same. You can do a one-time simulation or a daily, weekly, or monthly simulation. If we talk about a combined control simulation, like immediate threats intelligence, the game changes a bit. Instead of focusing hundreds or even thousands of methods and techniques against a single set of security controls, like an email gateway or endpoint security solutions, we focus one method or technique corresponding to a widely propagating current threat across all of the different components of a security architecture that would be responsible for detecting and deflecting this particular type of attack. Threats is all about detection. Can you keep them from getting in and establishing themselves? But you can test a single threat from start to finish with executions. And to do that, we use the full kill chain simulation methodology. And in this case, what you will be doing is defining each step of the process and telling the Cymulate system what it is you wish to do. So we can make it agentless. We could send this to actual users and add a little phishing awareness testing. Or we can have an agent pretend to be a user for a bit more flexibility and guaranteed infiltration. How will it infiltrate? Is this going to be an email, either via attachment or via link attack? Or are we going to simulate a drive-by compromise by having the agent interact with a link on a website? And again, these are all controlled by Cymulate and deployed from the Cymulate repositories, so you're not going to be going to any actual threat actor websites here. Let's do a download email with a link. That is quite popular these days. And then you will be able to determine what the file that will be attempted to be downloaded is going to look like. So let's go ahead and use a Word doc that contains poison macros, fairly common technique these days. But let's make it a little more difficult for the systems to catch. We'll put it inside a calendar invite. Calendar invites, ICS file types, are generally allowed because users do need to get calendar invites, but they should be checked for nested files that contain malicious attachments. And then we could say how it will execute. And the execution here can be any one of several different methodologies that start with user permissions, and then we'll attempt to elevate where necessary, or a couple that require that we start with administrative permissions. In this case, this is a more general test, so we'll use something that starts with user and elevates, and that will be, let's go with the process hider. And then finally, what behavior will be simulated? And we have a large number of resources, from ransomware methodologies to Trojans to worms, even the ability to kick off a lateral movement simulation as part of a full kill chain assessment. You can even import Purple Team templates, in other words, highly customized, individually set up executions and executables that spell out a particular type of attack behavior as you see fit. But for most of your interactions, you'll be using the built-in methodologies, and we'll go ahead and select one here. Let's see. How about a create file mapping? So this is a common technique that uses a file mapping trick to do the overwrite. Finally, we could say, let's make that Word document a stager. That means that the executable macros within the Word document themselves will not be outright malicious. They will wait 5 minutes, and then they will either attempt to perform something malicious or download additional code as per the requirements of this particular attack simulation. And then we have a complete attack from infiltration to actions on objectives that is, in this case, simulating something similar to a Medusa locker, but is taking advantage of some of the more common infiltration methods. So it is becoming quite common to see your company has signed you up for this virtual seminar. This is a method that we're seeing more and more of. And of course, the Medusa locker type attack is also fairly common across the internet right now. So we could see how effectively even more intricate security controls like AI-assisted behavioral-based technologies are able to deal with a current and propagating threat. All right, so we have walked through many of the different components of Cymulate, including what modules are available, how to set up different types of simulations, whether they're single control simulations that are sending hundreds or thousands of methods and techniques against one set of controls, or whether they're, like full kill chain, a combined control simulation. One set of methods and techniques testing all of the security controls from infiltration to execution to actions on objective. The Cymulate system is also designed to help with non-technical reporting. So all the reporting that we've looked at is also available offline. It could be seen in PDF form as a document. It could be seen in a CSV form for easy import into tools like Excel or into a database, whatever is most convenient for you with all of the technical details and information. But when speaking with more business-focused decision makers, the technical details can become obfuscating. They can hide the important stuff. Back to the dashboard, we're more than happy to work with you to answer any of the questions you have, to set up a proof of concept, to show you any of the vectors that we didn't specifically go through today, just reach out to your Cymulate sales team and we'll get the call set up and we'll give you all the information that you need and get you all set up for a proof of concept or a trial in your own environment. We'd be happy to do that. So please reach out to us, and thanks for joining us today.